This is part 7 of section 4.4, modeling with sinusoidal curves. So we're going to find a sine function that models the number of daylight hours in Paris. Okay? Now, modeling is we're not going to have a perfect function for this. It's just, we want to kind of find something that's the best fit, the kind of thing that where we can make estimates and projections based on the data we have. So if we're going to find a sine function that models something, then we're going to have something of the form y is equal to a sine of b times x minus c plus d. Okay, so this can be vertically stretched. The period can be lengthened or shortened. We can have a phase shift and we can have a vertical shift. Okay, so what they've done here is they plotted these values. In January, they get 8.8 hours of sunlight. In June, 16.1, and so on. So they mark this, and you can see it is the same basic shape as a sine or a cosine graph. Okay? What we need to do first is we want to find the highest and lowest values of y. Okay? So here in December, this is our lowest value. And in June, we have our highest value. Okay? And we will easily be able to get our A value and our D values from this. To find A, which is the amplitude, okay, the amplitude is 1/2 the largest minus the smallest. So this is 16.1 minus 8.3, which gives me 1/2 of 7.8. So that gives me 3.9. So 3.9 is my A value. Okay. Now to find D, basically what we're going to do is we're going to find the average of our highest and lowest values. So to find the average, it's like the amplitude, except we're going to add these values together. So we add them up, divide by 2. And we get 1/2 of 24.4, which is 12.2. So I now know my A value and my D value. I'm still looking for B and C. Okay. Now, our B value we can find from the period. Well, this thing, if this is true for every January, February, March, and so on, this repeats every year. Okay, so this repeats every 12 months. So the period is equal to 12. Well, the formula for period is 2 pi over b is equal to, and that has to equal 12. So 2 pi is equal to 12b, and solve this, you get b is equal to pi over 6. Okay, so what do we have so far? I'm just going to plug in the values we know here. So that would give me, so far, I am at y is equal to 3.9 times sine of pi over 6 times x minus c plus our d value, which is 12.2. Okay, so basically what I've got so far is I've got everything I need for my graph except for the horizontal shift. Okay? Now, if you look at this in blue is our graph if our phase shift is 0, without a horizontal shift at all. And I need to move this point over to here. Okay, so what we're going to do is we're just going to plug in the values for our largest y value. Our greatest y value happened in June. Okay, so June is the 6th month, and its value, our y value at that point, was 16.1. So that should be my highest value. What I'm going to do is I'm going to plug in this for x and this for y into the best formula we have so far, and that's going to allow us to find our c value. Okay, so if I take this x and this y and plug it in, I end up needing to solve 16.1 is equal to 3.9 sine of pi over 6 times 6 minus c plus 12.2. Okay, so I'm going to subtract 12.2 and then divide by 3.9, and you find out that must equal 1. Okay, so now we need to think about when is sine equal to 1. Sine is first equal to 1 when the argument is equal to pi over 2. So if we're taking sine of pi over 2, that's the first time we get 1. So what this tells us is that all of this, pi over 6 times 6 minus c, it needs to equal pi over 2. So when this happens, that's when we're going to get our sine value equal to 1. If you multiply both sides by 6 over pi to get rid of this, you'll end up with 6 minus c is equal to 3. And that tells us that our c value must equal 3. So now finally, we can deal with the phase shift as well. And our final modeling function is y is equal to 3.9 sine of pi over 6 times x minus 3 plus 12.2.